This is going to be one of the best videos you have ever come across when it comes to nomenclature of the organic compound. Because in this video here, you are going to learn and master how to name organic compound from scratch to finish. Whether you're a beginner or you're an organic chemistry student, you are still going to benefit from this video here. Because we always start from nomenclature of the alkanes, alkynes, acid, alcohols, and the rest. So you really want to stick to the end of this video here. You see structure like this. I'm going to dissect how you can name structures like this. Just like so, it's not going to be just a regular video you have come across. It's going to be an intense class. You understand? Because I promise you one here, by the time you finish watching this video, you should have become a master when it comes to nomenclature of the organic compound. So that by the time you get to the exam, or if you see any organic chemical structure, you should be able to name them easily. Do you understand? So let's get into it. I'm going to start with the nomenclature of the alkanes. So I'm going to start with this guy here. You don't have to be scared because I'm going to show you how to name this compound. So by the time I finish naming this compound here, you should have understand the rules, the various rules when it comes to naming of the organic compound. Now there's a reason why I'm starting from this one here, because I will use this structure to explain so many things for you. Just like explaining all the rules, the principles, and how to name alkanes. Like what I said, by the time you finish watching this video here, you're able to master the nature of the organic compound. So when I've been giving something like this here, now when some students see structure like this, they will be scared. Now I want you to understand something here. No matter how complex structure is, now once you have an idea of how to transform a skeletal structure to a fully displaced structure or a carbon chain structure, you should be able to name it, right? So if you see this structure here. Now, this is called skeletal structure. So, first, I want to teach you how you can transform skeletal structure to a carbon chain structure. Do you understand? Now, here we have this cyclo compounds, right? Now, here we have this guy, and here we have this guy here. So, the first thing I want to do here is that you want to transform this skeletal structure to a carbon chain structure. Each point in a skeletal structure represents a carbon atom. For example, if I ask like this, if I have something like this, say we have 1, 2, 3, 4, 5, 6, 7. It's okay. So 1, 2, 3, 4, 5, 6, 7. Now they are all single bond. They are all what? Please follow me close here. They are all single bond. Now this is a carbon atom. So you can say carbon atom. This is a carbon atom connected to this carbon atom, 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 connected to this carbon atom. 1, 2, 3, 4, 5, 6, 7. Can you see that? So each point represents what carbon atom. Now remember, carbon must have 4 bonds, right? Now this carbon atom is already connected to this carbon atom here with a single bond, right? So what happens here? This one have how many hydrogen? 3 hydrogen. So you have 1, 2, and 3. Here we have 1 and 2. Here we have 1 and 2. Here we have what? 1, 2. Here we have 1, 2. Here we have 1, 2. Here we have 1, 2, and 3. This is that. So this guy is sent to this one here. Now this is called skeletal structure. This is called fully displayed carbon structure. Now you can condense it. Now you can group it here. C with 3 hydrogen. So it's going to be CH3. Can you see that? That is, this carbon atom is having 3 hydrogen. So you can write in a group. Connected to the other one, here we have CH2. Connected to this other one, here we have CH2. CH2. 1, 2, 3, 4. CH2 and CH2, right? So you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Do you see that? So this one is the same with this guy, and this guy is also the same with this guy here, right? Now in the exam, you can see it as this way here. Remember, CH is how many? 1, 2, 3, 4, 5, 5. So you can write like that as what? CH3, CH2, 5, CH3. So it's very important to know how to transform what? Skeletal structure to a fully displayed structure here. Do you understand? So this one is also the same with this guy, and this guy also the same with this guy, and this guy also the same with this guy here. Very important. Now let's go on that one. Now, if for example here we have this guy here, we have this compound here, right? We have this compound here. How do you transform this compound to a fully displayed structure? Carbon chain. Very important. Please pay close attention. So here we have 1, 2, 3, 4, 5, 6, 7. So you can do it like this: 1, 2, 3, 4, 5, 6, 7. Right now, if you 1, 2, 3, 4, 5, 6, 7. Right. So if you check very well, at this carbon here, we should go to 1, 2, 3. At this carbon here, I have this extension here. So 1, 2, 3, 1, 2, 3, 1, 2, 3. I have this point here. This carbon atom is connected to this carbon atom, right? And this carbon atom is connected to this carbon atom, and this is connected to what? To this carbon atom. Do you understand? Now go to the other one here. Here we have, sorry, this carbon is connected to this carbon atom here. If you come here, this is connected to this carbon atom. So here we have 1, 2, 3, 4. So going to be 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Can you see that? So the next thing you want to do here is what? Place your what's your hydrogen. So you're going to be 1, 2, 3. This is that. So here we have 1, 2, right? This guy is already having 3 bonds here, right? So you don't need 1 hydrogen. So you're going to be 1 hydrogen, right? Now this one, the same thing, it already have 1 hydrogen. It only need 1 hydrogen. So we're going to be 1 hydrogen here. So I have what? 3 hydrogen, right? The same thing here, right? 1, 2, 1, 2, and 3, right? So your what is to fill the hydrogen here, the right amount of numbers of hydrogen, right? Same thing here: hydrogen, 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 and hydrogen. This is that. So we have converted this guy, this one here. But now let's group it together. Let's group it. Just now, let's what? Group it. So if you should group it here, what are you going to get? You're going to be CH what? 3, right? CH3. Next one is what? CH2, right? Next one is what? CH, right? Now this one is having CH, CH3, and what? CH3. Can you see that? So the same thing here. This one is having what? H and what? CH3, right? Now if you check this one here, here we have CH, here we have CH2, 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 and what? CH2, right? Now here we now have what? CH2 and what? CH3. So that skeletal structure I'll be converted to this, and so I'll be converted to this here. So you will now start what? Naming them, right? Now, but we have that one there. Let's use the knowledge of what we have done here to draw the structure of this guy, because this is where I want to actually start teaching you how to name organic what? Compound, how to name organic structure. So now each of these points here, let us say here we have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon what? 8. So now let us say we have 8 carbon here, because here we have 1, 2, 3, 4, 5, 6, 7, 8. Or you can say 1, 2, 3, 4, 5, 7, 8. So if I start from here, 1, 2, 3, 4, we also have all these ones attached to it, right? So now let's start from there, because you need to start from somewhere. So here we have the first carbon here. So we have 8 carbon. 1, 2, 3, 4, 5, 6, 7, 8. Can you see that? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, this is carbon atom here. This one does not have any substituent here. So it's going to be 1, 2, 3. I can't about 3. I have a chloro group. This is that. I can't about 3 because here we have 1, 2, 3. 1, 2, 3. I have a chloro group. So here we have chlorine. Can you see that? Now, I can't about because here we have 1, 2, 3, 4. I can't about 4. I have this cyclo here. So I can just say this what? Cyclobenzene. Now let us say here. Let us say here. Cyclohexane, right? Cyclohexane, right? This one here. Then this carbon atom, you also carry this 1, 2, 3. You also carry this. Now, because if you share this carbon atom, here is carbon 1, here is carbon 2, here is carbon 3, here is carbon 4, right? This carbon 4 is carrying the whole of this one 1, 2, 3. So it will be 1, 2, 3. Can you see that? 1, 2, 3. Okay, sorry, not here. It's carrying what? 1, 2, 3, 4. You're going to be what? 1, 2, 3, right? So yeah, because 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one just carry 1, 2, 3. Now you can also write it. You can also write it 1, 2, 3. Do you see that it's the same thing? Now, yeah, because 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6. Now this carbon 6 is that what NO? So here we have NO2, right? So now 1, 2, 3. 1, 2, 1, 2. So this structure you are seeing here is also the same thing with this guy here. The next thing you want to do is so what? Give them the appropriate numbers of what? Of hydrogen atom. So this one you go to have what? CH3, right? Then in this carbon atom here we have 3 hydrogen. Here we go to how many hydrogen? 2 hydrogen. So it will be CH2. Now this one is only having 3 bonds here, right? Go to have 1 hydrogen. So it will be CHCl, right? Then you have now this one is C. Now then you have this cyclohexane. The remainder is going to be CH2, CH2, and what? CH3. Understand this here? CH2, CH2, and what? CH3, right? So you have this other one here. CH, here we have what? CH2, CH2, and what? CH2, right? Now here we now have NO, sorry. Here we have CHNO2, right? So we have what? CH2 and what? CH3. So now this structure you are seeing here is the same to this guy here. Do you understand? It's the same to what we, now this one you are seeing here is the same to this guy here. So how do we name this structure here? This is where the class starts from now. Because I've just shown you how to transform what a skeletal structure to what a fluid display structure or fluid carbon structure. It's very important to know this here. So now let's start naming organic compounds. Now let's start naming organic compounds. So what are the various rules? Imagine you have been given something like this here. What are the various rules you can use to name compound like this? Do you understand? So I'll wipe this place out. So now let's name this one here. So what are the various rules in naming alkane? So let's take it step by step. Of course, this one is an alkane because they are all single bond. They are all what? Single bond. So it's an alkane. So now let's take rule number 1. To name alkane, rule number 1 states that take the longest continuous carbon chain. Take the longest continuous carbon chain and name it as the parent chain. That's what the rule number 1. So let's guys one here. From here to here, how many carbon atoms do you have? From here to here, how many carbon atoms do you have? From here to here, how many carbon atoms do you have? So you must make sure that you take what the longest continuous carbon chain. The longest continuous carbon chain is the chain that contains the highest number of carbon atoms. So the chain that has the highest number of carbon atoms is the longest continuous carbon chain. So your mission before you start naming organic compound, the first thing you have to do is to make sure that you get the carbon atom, you get the chain that have the highest number of carbon atoms. Just so let's go get to it. 1, 2, 3, 4, 5, 6, 7, 8. 8, right? So let's count from here to here. 1, 2, 3, 4, 5, 6, 7. Here we have 7. Here we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8. Can you see that? So here we have 8, 7, 8, right? So now there are 3 chains here. We have the one that have 8 carbon atoms. We have the one that have 6 carbon atoms. We have the one that have 8 carbon atoms. Of course, this 7 is out already. Just so the highest number, the chain going to be either this guy or this here, right? 8, 8. And look at the 8 members of the alkane is called octane. It's called what? Octane. Octane. Now, this one we are now going to move to the second rule, where it calls what? Naming organic compound, naming of the alkane. Right there. Take them. If two chains have the same highest numbers of carbon atoms in the compound, the chain with the highest numbers of substituents becomes the parent chain. Do you understand? I will explain to you. Now, in this case here, we have from here to here as 8, and from here to here as 8. Both of them is what is octane. But both of them cannot be the parent chain at the same time. One must be the parent chain, while the other will not become what? Side chain. Do you understand? So the chain that had highest numbers of substituents, just substituents, we have to call substituents. Substituents, the highest numbers of substituents. And he said that, what do you understand by substituents? Substituents are those chains that is attached to the parent chain. So those group of atoms or chain that is not counted among the parent chain, they are regarded as substituents, right? Now let's look at it very well. If you should take from here to here, let's say take from here to here. Now from here to here, now 1, 2, 3. Now remember, if I should take from here to here, this guy is a substituent, right? This is a substituent. This is a substituent. This is a substituent, and this is a substituent, right? So if I start from here, 1, 2, 3, 4, 5, 6, 7, 8. How many substituents do I have? I have 1, 2, 3, 4, 5. I have 5 different substituents. Just so if I start from here to here, I have a different substituents. I'm going to draw this thing again so you understand this thing very well. So you have, right? Now, 1, 2 from here to here, we have a substituent 1, 2, 3, 4, 5. 5 different 5 substituents. Right, the 5 substituents, right? Now, but now let's take from here to here, because from here to here is 8, right? From here to here is 8. So we have taken from here. So now if you start from here to here, right? You start from here 1, 2, 3, 4, 5, 6, 7, 8. Now, how many substituents do we have? We have 1, we have 2, we have 3, and we have 4. It's okay. Now, the case here we start from here to here. Right there. So if you take from here to here, we have what? 4 different substituents. 4 substituents. 4 substituents. Now the rule says that if the compound have the same chain that have equal numbers of carbon atoms, right there. Now the chain that have the highest numbers of substituents is what is the parent chain. That is what rule number 2 is what is the parent chain. Now if you check very well, this guy have 5, this guy have 4. 2 of them cannot be the parent chain at the same time. 1 must be the parent chain. Automatically, this guy that have 5 is now what the parent chain, right? This guy is not the parent chain. So we discard this guy here. Do you understand? We discard what this one here. So this is now going to be what our focus. That what rule number 2. Now rule number 3. Rule number 3 states that if 2 or more substituents are attached to the parent chain, if two or more substituents are attached to the parent chain, the chain must be numbered in a way. The summation of the position of the substituents must have the lowest possible number, which I'm going to explain to you. Now, here we are from here to here is parent chain. Now, the parent chain can be numbered in both directions. You can either start from here or you can start from here. The rule says that you must number it in such a direction that when you sum the position of the substituents, it must have the lowest possible number. Now, I'm going to draw this thing out again. Here we have CH3. Okay, please pay close attention here. So I can start my number from here, and I can also start my number from here. The goal here is a number in both directions, so I can see the one that has the lowest possible number. So when I start from here, we have 1, 2, 3, 4, 5, 6, 7, 8, right? Same here. Let me start from here. We have 1, 2, 3, 4, 5, 6, 7, and 8, right? So now let's sum that position. If you sum position here, we have 3. I can number 3 have a substituent, right? So it will be 3 plus. I can number 4 have 2 substituents, this and this. So it will be 4 plus 4. 4 plus 4, right? I can number 5 have a substituent plus 5 plus 6. Can you see that? Here we have what? 22. So when you sum that position, it's going to be what? 22. Then we start our number from here, right? Now let's start our number from here. Here we have 1, 2, 3. So here we have 3 plus 4 plus 5 plus 5 plus 6. Right there. So here going to be 23. We're going to be what 23. We're going to be what 23. Can you see that? So if you say that, yeah, we add what my parent chain obtain, right? Now, but when I start my number from here, it gave me what 22. When I start my number from here, it gave me what 23. So the rule said that the one that add lowest possible number, either when you sum their position. So this one is the right direction. This is what the right direction. Very important. So I write this place add. White boys for art here. White boys for art. Now let's move to what rule number what 3. Now when name is the following must be noted. That you know what take the following here. Now when name is A, the first thing here A. Numbers and numbers are always separated by a comma. Either numbers and numbers are always separated by a comma. So for example here we have 1 1 or 1 2. It says that what does it mean? It means that numbers and numbers are always separated by a comma. So when you're naming here, you have to what take note of this one here. You must separate number from number by what? By comma. B. Numbers and alphabets are always separated by what? By a dash, hyphen. So if for example here we have number and alphabet here, when I'm naming, you must separate it by what? By an hyphen. Like for example here, 3 chloro. Either number and alphabet are always separated by this dash here. It's very important. Or 4 methyl. Now what does it mean here? You only separate number from what? Alphabets. By what? By an hyphen here. Just very important. C. These substituents must be arranged alphabetically. These substituents must be arranged alphabetically. That is, you must arrange substituents alphabetically. So a good example is going to be 4 bromo 2 methyl. Now what does it mean? B will come before in alphabetical order. This is that B will come before what? In alphabetical order. So you must arrange substituent alphabetically. Do you understand? Note, very important. The prefix die, tri, tetra, penta are always ignored in alphabetical order. Are always ignored. So you can see dimethyl, triethyl. Now the di are always prefix. If for example here we have 2, 3 dimethyl. Now what does it mean? It means that this di just show that there are 2 methyl. So this D is not used when it comes to alphabetical order. You use what? The M. So the prefix di, tri, tetra, penta are always ignored in alphabetical order. That is, when you arrange the substituent in alphabetical order, you always ignore this one here. You always ignore what this one prefix. But the prefix iso, comma, sec, comma, cyclo, comma, text are not ignored in alphabetical order. So you don't ignore all this one in alphabetical order. For example, here we have isopropyl. Hi there. Isopropyl is the name of one of the propyl group. Just isopropyl. For example, here we have sec butyl. Here we have sec butyl. Hi there. It's called secondary butyl. Now we also have called tet butyl. So please take note of this here. The prefix di, tri, tetra, penta are always ignore them. But the prefix iso, sec, cyclo, tet are not ignored in alphabetical order. So these are things you need to put in mind when you are naming substituents. When you are arranging substituent in alphabetical order. It's very important. So these are ignored, but these are not ignored. Do you understand? Now let's look at common substituents. Another thing you want to put in your mind is called common substituents. common what substituent. So let's look at what common substituent, common alkyl group, common alkyl group. Now these are group that you must understand. They are called common substituents. Now the first one is going to be what CH3. CH3 is called what methyl. Is what is methyl. CH is what is methyl. You have to know it. Now the next one is what is CH3. CH2 is what is an ethyl. Is ethyl. So whenever you see CH3, CH is what is an ethyl. The next one is what CH3, CH2, CH2. Here we have what? Here we have what? Propyl. This is here we have what? Propyl. Now here we have CH3, CH3. Here we call isopropyl. It's called isopropyl. Iso what? Propyl. We are going to look at it very well as we move on. Now here we have CH3, CH2, CH2, CH2. Here we have what? Butyl. Here we have what? Butyl. Here we have what? Butyl. Now here we have CH3, CH2, CH3. Here we have what? Sec butyl. Sec what? Butyl. It's okay. Now the last one I want to show you is what? CH3, CH3, CH3. Here we have what? Tet butyl. Tet what? Butyl. So you have to take note of all these common alkyl groups. They are the ones you are going to see most when you are naming organic what compounds. Now we also have other what substituents. You have to know. Cl, it's called what? Chloro. Here we have what? Chloro. Cl, we have what called chloro. Bro is what? Is bromo. Bromo. Right? Bromo. Here we have F, it's called what? Fluoro. Fluoro. Here we have what? I is called iodo. Just and here we have NH2 is called what? Amino. Here we have amino. Here we have what? NO2 is called what? Nitro. This is that. Now here we have this one here. Here we have what? Phenyl. So this phenyl is when benzene is what is a substituent. When benzene is what is a substituent. This is that. Here we have CN. It's called cyano. So these are things you have to pay close attention. These are the common substituents. All these ones are called the alkyl. These are what common substituents you always see mostly when it comes to what nomenclature of the organic compound. So you have to take them down. Please pause the video and take them down now. It's very important. So now let's move over to this place here. Let's finalize the nomenclature of these compounds. Check very well. If you look at this one here, here we have chloro. Right there. This one called cyclohexyl. Cyclo what? Exile. Yes. Here it's called propyl. Here we have what? Propyl. Can you see that? So it means that carbon 3 is having what? A chloro group, right? So going to be 3 chloro. Right? The next is what? Is cyclo. So you have 4 cyclohexyl. 4 cyclo what? Exile. Now account number 4, account number 5 have what? Propyl. Two of them are the same, propyl. So it would be 4,5 dipropyl. This is that. Now this is the reason why I combine them together. One is account number 4 propyl. One account number 5 propyl, right? So when you combine it together, it's going to be 4,5 dipropyl. It's okay, 4,5 what? Dipropyl. So that way is like that. Now account number 6 have what? A nitro. So you have 6 nitro. Can you see that? So now let's arrange them alphabetically. Now what the parent name? Parent name is what? Is octane. The parent name is what? Is octane. Very important. So if you should check very well, see this chloro will come before cyclo, and cyclo will come before N, and N will come before what? P. Remember, I tell you that the prefix "da" is always ignored. You always ignore it. So now, if you should now arrange it alphabetically now, C will come before what? Chloro will come before what? Cyclo. Cyclo will come before what? Nitro. And nitro will come before what? P. Do you understand? So the name is going to be trichloro, trichloro, right? Trichloro. Give now what? 4-hexyl. 4 what? 4-hexyl. 6-nitro. 6-nitro. Right? Then 4,5-dipropyl. 4,5-dipropyl. 4,5-di what? Propyl. Then you have what? Octane. That is it. You can see how easy it is now. So this is the name of this one here. Hope you understand. Hope you understand. So that is the name of this one here. Now let's do some practice problem. So let's look at some practice problem when it comes to what? Nomenclature of what? Of the alkanes. So I'll be able to what? Establish the various rules when it comes to nomenclature of the alkanes. So let's look at some practice problem, patterns, and ways you are going to see question in the exam. So let's look at the ones at the board here on the board. So let's look at the what? First one. Now remember what is the rule of nomenclature? The rule states that take the longest continuous carbon atom, right, and name it as well as the parent chain. So now if you look at this compound here, now one of the common mistakes many people make, they will just take 1, 2, 3, 4, 5, 6. They will say 6 is what parent chain, which is a lie. So return from here to here, how many are we going to have? 1, 2, 3, 4, 5, 6, 7, 8, 8. So here we have 6, here we have what? 8. 8 is the longest, so is what is obtained, right? So if you stay from here to here, you have to have this guy, and this as what? As the what? Substituent. So we have 3 substituents, right? Here we have what is called phenyl. Here we have what we call methyl, and here we have what? Nitro, right? So now the next thing I want to do here is what? Number it such a way that when you sum their position, when you sum the ratio of this guy, to have what? Lowest possible number. So if you start your number from here and you start your number from here, which is going to have your longest, you should go to have the lowest possible number when you sum that position. Of course, it's going to be from here. Just so if you start from here, here we have what? 1, 2, 3, 4, 5, 6, 7, 8, right? So it will be 2 plus 4 plus 5, right? So it will be 2 plus 4, 2 plus 4 plus 5, which is going to be 11. Yes, I wish you go to what? Be 11. 2 plus 4 plus 5, which is going to be 11. But the other hand, if you start from here, here we have if you have something like this: 1, 2, 3, 4, 5, 6, 7, 8. So you have 4 plus 5 plus what? Plus 7. Can you see that? 4 plus 5 plus 7. What are you going to get? 16. Can you see that? Going to be what? 16. Of course, I want to start from this point here. So now when you are naming, make sure you are very, very careful when you are what? Numbering. So of course, you have to, this one is have what? The lowest possible number. So here we have this one here. So you have 1, 2, 3, 4, 5, 6, 7, what? 7, what? 8, right? So if you check very well, here we have methyl, here we have what? Methyl. Here we have methyl, here we have nitrate, here we have phenyl. M will come before N, and N will come before P in alphabetical order. Do you understand? So the name is going to be 5. Now, methyl you can by what? 5, right? Yes. 6, 7, 8, right? So methyl is accounted by what? 5, right? So it will be 5 methyl, right? Then accounted by 4, I have what? A nitro, so it will be 4 nitro, right? Accounted by 2, I have phenyl, you go 2 what? Phenyl octane. Can you see that? So that is the name of this compound here. That is what is name of this what compound. So let's look at this one here. Here we have, of course, this is what is the skeletal structure. Skeletal structure, you can just what name it straight, right? So we have to tell you the longest continuous carbon chain, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have this guy, this guy, this guy, and this guy. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, if you have actually mastered the nomenclature, you find that you start from here. Do you understand? Now, what is the name of this guy? This guy is called bromo. This guy is called bromo. What is the name of this guy? Here called isopropyl. Isopropyl. Here it's called tet-butyl. It's okay. Tet what? Butyl. You have to know all these consonants here. What is the name of this guy? This guy's name is called ethyl. Is okay. So we have to start along from here. My parent name is what? Is decane. Decane. Yes, that is what my parent name. Decane. Yes, my parent name is what? Is decane. So I now going to do it here. So in the nomenclature, B will come before what? E. B will come before E, and E will come for what? I, right? And I will come for what? T. So that's what pay close attention to this one here. B in alphabetical order will come before what? E, and I will come before what? T. Do you understand? So what will that be the name? Bromo is accounted by what? 4. So it will be 4 bromo. 4 what? Bromo. Right? Then 7 ethyl. 7 what? Ethyl. Right? Then 3 isopropyl. 3 isopropyl. Right? Then 5 tet-butyl. They have 5 tet-butyl. Right? Then what? Decane. That is it. So 4 bromo, 7 ethyls, 3 isopropyl, 5 tet-butyl, decane. Do you understand? So now we are done with this one here. So we have done this here, I've done this here. Now the next one I want to look at is this one here. Now this is the way and format most exam normally comes out in the exam. This is the way and format most exam do come out in the exam. So now if you look at this condensed structure here we have CH3 twice. That is, this carbon here is having what? 2 methyl group. So here we have a carbon atom carrying out 2 methyl group, CH3 and what? CH3 and a hydrogen. Do you understand? Because majority of the time you may not see it like this. You may not see it like this. You may see it like this in your exam. So here we have this carbon here is kind of 2 methyl group. So this carbon here is kind of an hydrogen. Then 2 methyl, this guy and this guy here, right? Then you have what? CH what? 2. Now this carbon is carrying what? 2 methyl group. Can you see that? Then this one here is carrying what? CH2. Then you have what? CH what? And a bromine group here, right? Now if you check this one here, this carbon is carrying what? A hydrogen and what? 2 methyl. So you have CH3 and what? CH3. Here we have what? Hydrogen. That is it. So how are we going to what? To name it now? Because this one is an interpretation of this one here. Now that is why you must learn how to draw fully display formula. So that you know how the atoms are being combined, you know the substituents, and you know the bond connection. So yeah, of course, I will take 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So if you take from here to here, I have this guy, I have this guy, I have this guy, I have this guy as what? As a substituent. As a what? As a substituent. So, but I'm not too sure here. I have to what? Number it from both sides to see the one that because where am I setting my number from? I don't know. So I must take from both sides to see the one that give you the lowest possible number. Just so if you're not too sure, you have to what number from both sides to see the one that have what lowest possible number when you sum that position. So if I start from here, you have 1, 2, 3, 4, 5, 6, 7, 8. Now, carrying that 2 add in methyl, it's going to be 2 plus, right? Carrying that 4 add this and this, so it will be 4 plus 4 because 1, 2, 3, 4, right? Carrying that 5, no having carrying that 6, here we have plus what? 6 plus what? 7. So once it's on that position, 23. So when you sum all this one together, you're going to give me what? 23. When we start from here, right? You're going to give me what? 23. But now let's start our number from here first. Let's see what we're going to get. So you have 1, 2, 3, 4, 5, 6, 7, right? And what 8. So what does it mean? You're going to be 2 plus 3 plus 5 plus 5, 5 plus 5, yeah, right? Plus what? 7, right? So here we have 22. So when I start from here, it gave me what? 22. When I start from here, it gave me what? 23. So this one is what is my right number. Do you understand? So that's why you need to be careful when you are what numbering. You need to watch checkmate, the one that have the what lowest possible what number. Do you understand? So what I'm going to do here, B will come before any other one here. So it's going to be 3 bromo, right? 3 bromo, right? Now I can number 2 add what in methyl, so it will be 2. I can number 5 I have 2 methyl, it's going to be 5, 5, right? I can number 7 I have what in methyl, so it's going to be 7. I'm in 4, and the prefix 4 is what? Is tetra, so it's going to be tetramethyl. Tetra what? So 2, 5, 5, 7 tetramethyl octane. Octane. Do you understand? So that is the name of this one here. So we have named this one. We have named this one. We have what? Named this one. So let's name this guy here. Right? Let's name this guy here. So I'm just trying to see how I can what perfect the nomenclature. Do you understand? So that's what I'm trying to do here. Because what's the master the nomenclature of the alkenes? What's the master the nomenclature of the alkenes? The nomenclature of the alkenes, alkynes, and the rest is much easier for you. So that is why this is just like explaining the various rules in what naming alkenes, so that by the time you get to the other functional group, it will be much easier for you. Hope you understand. So now let's look at this guy here. Let's look at what the last one. Let's look at the what last one. Here we have 1, 2, 3, 4, 5, 5. Now, if you check very well, if you start from both sides, for example, if you start from here, 1, 2, 3, 4, 5, 2 and 4, right? 1, 2, 3, 4, 5. 2 and 4 is what? 2 plus 4 equals to what? 6, right? Now, if you start from this other end to 1, 2, 3, 4, 5. 2 plus 4 is what? Is 6. So one number from both sides gave me what? 6 and 6. So the question will now be, where are we starting our number from? This is where I'm going to consider what the substituents. Here is what is bromo. Here is what is chloro. Do you understand? Here is bromo. Here is what is chloro, right? Now in alphabetical order, B will come before C. So because variation of the what alphabetical order, B is coming from C in alphabetical order, the B will now have the lowest possible number. So now going to be what? 2 bromo. 2 bromo. Here we have 4 chloro. Here we have what? Pentane. Pentane. That is it. So now let's look at what nomenclature of other functional group. So I'll be able to establish how to name alkanes. If you want to know how to name alkanes, every other function are very, very easy. Do you understand? So the only thing you want to understand here is that is the functional group you are going to take note of. So now look at the first one here. So this is a double bond here. Right there. A double bond means what? Is an alkene. Is what? Is an alkene, right? Now, what you want to understand here is that whenever you are naming alkene, now the double bond must be considered. So instead that you must take the chain you must take the longest continuous carbon chain that contain what the double bond right there. So the chain that contain the double bond is the parent chain, and it must be numbered in a way the carbon atom that carry the double bond must have the lowest possible number. So there are two things here. You must take the chain that have you must take the chain that have the longest continuous carbon atom that carry what the double bond. So the longest continuous carbon atom that carry double bond is the parent chain. Right, what number one. Number two, you must number it in a way or in a direction. The carbon atom that carry double bond must have the lowest possible number. So that's key two things you have to put in mind in nomenclature of the alkene. So if you look at this thing here, from here to here there is no double bond, but from here to this other point here, that's where we have double bond. So we have 1, 2, 3, 4, 5, 6, 7. 7. So 7 member of the alkene is called heptene. It's called heptene. Heptene. This is that called what? Heptene. Remember, this is OH, this is what carboxylic acid. We want to name all these things. Heptene, right? Now, of course, I want to start from here because here you're going to be one like carbon 1. So it'll be 1, 2, 3, 4, 5, and what? 6, and what? 7, right? That is the double bond is a carbon what? 1, which start from here. 1. So you not go further before you see your what? Double bond. So it'll be what? 1 heptene. 1 heptene. Or you can say hept. 1 what in. What did it mean? Mean that 7 carbon atom carrying a double bond at carbon number 1. Do you see that? So if you stay from here, this is our point here. Here we have this guy, and this guy as well as substituents. You know what this guy is called? What? Ethyl. Is ethyl. Here it's called what? Bromo. Here we have what? Methyl. Right? So what will happen here? B will come before what? E, and E will come before what? M in alphabetical order. Do you see that? So what will that be made? Then going to be 6 bromo. 6 what? Bromo. Here we have 3 ethyl. 3 what? Ethyl. Then what? 6 what? Methyl. 6 methyl. What again? Going to be hept 1 in. So going to be hept 1 what in. That is it. As easy as that. It's not difficult. It's not what? It's not difficult. So now let's take on that one. Now let's take on that one. When it comes to what? To the what? Alkene. Let's take on that one. Okay, now let's look at this one here. This one have what? A double bond, right? This guy have what? A double bond. So this double bond here. Remember, I tell that each carbon atom right here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So it's going to be decene, right? Decene, yes. So because there's a double bond here, right? Now remember, double bond must have the lowest possible number. So my name will go to start from here. My name will not go to start from here because if you start from here, I have 1, 2, 3, 4, 5, 6, 7, right? But when I start from here, 1, 2, 3. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. Can you see that? So it's going to be 3 decene or 3 what in. Now this is what the parent chain. What does it mean? It means that 10 carbon atom chain with a what? Double bond account by what? 3. That is meaning. Now we have our substituent here. Here we have what? Here we have this phenyl. Here we have phenyl. Can you see that? Here we have what? Phenyl. Here we have what? Nitro. Here we have chloro. Here we have what? Methyl. Here we have what? Methyl. Right? Here we have what? Methyl. So now, when arranging alphabetically, we should come first. C will come before what? N, and N comes before N, and N comes before what? F or P. So when you arrange it alphabetically, so I can about 3, I have a chloro, so it's going to be 3 chloro, right? Now, I can about what? I can about 6, and then I can about 7, I have what? Methyl. So I can about 6 is about 2 methyl. So it will be 6, 6. 6, 6. The account about 7 also have the methyl here. 6, 6, 7 trimethyl. Try what? Trimethyl, right? The account about 2, I have what? A nitro. So it will be what? 2 nitro, right? So it will be deck 3 in. So it will be deck 3 what? In. So this is what name Alkenes. Just and these are so. Once you keep on practicing, it will what get used to you. Yes, to get used to you. So this is what make sure this guy here. So we are done with Alkene. So every other thing follows. So they look at what alcohol. When talk about the multiplication of alcohol, because there's OH here. Now when I see OH means what it's an alcohol. So why we so here we have alcohol OH. I get so here we have alkanol. Alcohol is now about alkanol. I get it is being derived from the corresponding alkane. Remember, here we have alkane, right? When you remove the E, you play with OH, then I will got alkanol. Hope you understand. Now, let's look at what the carbon chain. Here we have 1, 2, 3, 4, 5, 6, 7. So let it be heptanol. Just an heptanol, several carbon atoms to OH, heptanol, right? So it's going to be heptanol, right? Now, whenever you have named alkanol, just like the way you have named alkene, you must number in favor of the OH. That is the carbon atom that bears the OH must have the lowest possible number. So we don't understand it now. Of course, I'm going to start from here. It's going to be 1, 2, 3, 4, 5, 6, and 7. It's okay. 1, 2, 3, 4, 5, 6, and 7. So now let's get the parent name first. It's going to be heptanol. Heptanol. Can you see that? Heptanol. Right? So the OH that comes back to will be 2 heptanol. Or you can say heptatol. This is that heptatol. Yes. Then so if in this one here, if you use any of it, you are correct. 2 heptanol or heptatol, anyone, right? So here we have bromo, here we have chloro, here we have what methyl. B will come first before chloro, before methyl, right? So arrange them alphabetically. Here I want to get 5 bromo. Here we have 5 chloro. Here we have what 6 methyl. Here we have what heptatol. That is it, heptatol. 5 bromo, 5 chloro, 6 methyl, heptatol. Correct. This is that. So that is for what nomenclature of alcohol. Let's do some practice problem. It's still the same thing, it's still the same nomenclature. It's still repetition of what everything. See the same thing. So you go ahead and name some for me. Drop like the comment section. CH3. Here we have you have CH2, COH, here we have CH2, you have what? BROH, CH2. Okay, go ahead and name some from leave at the comment section, right? Go ahead and name some from leave at the comment section. So let's look at this guy here. Here's the double bond. It's going to be what? Alkyne. Going to be what? Alkyne. The notation of the alkyne is the same to that of the alkene. Just that the EN will change what to YNE, but it's follow the same pattern. So here, 1, 2, 3, 4, 5, 6, 7, we're going to be heptine. Heptine. This is that it's going to be what? Heptine. Now, what does it mean? It means that the compound have 7 carbon atom with a triple bond. Now remember, the triple bond must have the lowest possible number. The triple bond must have the lowest possible number. So it's going to be 1, 2, 3, 4, 5, 6, and 7. So it's going to be 2 heptine. So it's going to be 2 heptine. 2 heptine. Or hept 2 what? Ine or heptine. C we come first. So it will be 6 chloro, right? 5,5 dimethyl, 5,5 dimethyl, 5,5 dimethyl, hep2ine, hep2 what? Ine, hep2ine. That is it. Just that what you have here. Then let's look at what the last one. Carboxylic acid is called carboxylic acid. Also known as alkanoic acid. Also known as alkanoic what acid? Alkanoic acid. Right there. Alkanoic what acid? Alkanoic what acid? So now how many carbon atoms do you have here? 1, 2, 3, 4, 5, 6. It's going to be hexanoic acid. It's going to be hexanoic acid. It's going to be what? Hexanoic what acid. Now, this carboxylic acid here is always the carbon 1. So the functional group is always my carbon 1. So here we have 1, 2, 3, 4, 5, 6. So please, if you have any question, leave it at the comment section. Do you understand? If you have any question, leave it at the comment section and I will respond to you. If you need any assistance at all, please chat me through my phone number. You get on WhatsApp and I will respond to you. So here we have what? Ethyl. Here we have what? Phenyl. It's okay. Here we have what? Ethyl. Here we have phenyl. So we're going to do what? 3 ethyl, 4 phenyl, then hexanoic acid. That is it. So I believe this video I've explained a little bit when it comes to the nomenclature of what of the organic compound. We still have so many things coming up. So please, if you are not subscribed, consider subscribing. Can you share this video with your friends? Please give this video a like so that you can spread to other persons. So please leave your question at the comment section and I will respond to every single of your questions at the comment section. Do you understand? See you in the next video. Now, if you want to learn the nomenclature of aldehyde and ketone, you can check out this video here. You can learn what nomenclature of what aldehyde and ketone. See you in the next class.